Today we're going to be learning another method for solving equations algebraically. This method of solving systems is called elimination. This is a great method to use when you have two equations that are both in standard form. The first example we're going to do is x plus 3y equals negative 2 and x minus 3y equals 16. With elimination, we are trying to get rid of one of the variables, and we can actually do that by either adding or subtracting the two equations with each other. So here's what that's going to look like for our first example. I am going to add these two equations together. I do need to make sure that like terms are all lined up with each other. But when I do that, 1x plus 1x is 2x. Positive 3y minus 3y is a zero pair. That's what cancels. That's what gets eliminated. And negative 2 plus 16 is positive 14. And then from here, can divide both sides by 2 to get x equals 7. All right, I have one of the two variables. To get the other, I'm going to pick an equation. I'm going to just choose the first one, only because it came first, and substitute in a 7 in place of x. And now I can go ahead, solve a two-step equation, subtract 7 from both sides. So 3y equals negative 9. And when I divide by 3, y equals negative 3. And next we can put those together in an ordered pair. X is 7 and y is negative 3. So that would be the solution to this system of equations. All right, another example like that, I can see that negative 1y and positive 1y will cancel. So again, I can just add those two equations together. 2x plus 4x is 6x. 9 plus 21 is 30, and then those two cancel out to zero pairs. That's the term that gets eliminated. Okay, divide both sides by 6 to get x equals 5. All right, I'm going to pick an equation. I'll still do the first one. Again, both equations will work. That one just has a smaller coefficient for x and a smaller constant, so it seems like it might be easier. Okay, substitute in a 5 in place of x. And then go ahead and continue solving. So 2 times 5 is 10. Subtract 10 from both sides. So we'll get negative y equals negative 1. And then divide both sides by negative 1 so that we end up with the value for positive y. And finally, combine those into an ordered pair, 5, 1. All right, sometimes elimination won't work unless you get coefficients that will cancel out. So in this example, neither of those will cancel. Negative 6x and negative 2x, those aren't zero pairs. Positive 5y, negative 4y, those aren't zero pairs. But we can actually manipulate the equation to get a common coefficient that will cancel out. So looking at this, if I want to try to get these two to cancel out, if there's a way to change the negative 2 into a positive 6, then they'll cancel. And I can actually change that into a positive 6 by taking every single term in the equation and multiplying it by negative 3. So now if I distribute that all the way through, the second equation would become positive 6x plus 12y equals negative 42. Okay, now I'm just going to recopy the starting equation. Negative 6x plus 5y equals 25. So the value of the second equation is still the same. It would still be graphed the same and look the same in both representations. But now, when I add these together, the 6x's will cancel out. So now I'm left with positive 17y equals negative 17. divide both sides by 17, and y is equal to -1. All right, to get the x value, I need to go back to one of the two original equations. So this time I'll use this equation again. I'm just looking at whatever coefficients are smaller. That one looks like it might be a little easier to work with. So -2x minus 4y equals 14. Substitute in a -1 in place of y. And then -4 times -1 is +4. Subtract 4 from each side. So -2x equals 10. Divide by -2. And x is equal to -5. So ordered pair solution would be -5, comma, -1. Okay, next problem. This one is kind of similar in the sense that it doesn't have coefficients that are going to cancel each other out, but I can do that. So I can either multiply by -2 to turn that into -6x, or I could multiply by -3 to get the y term to cancel out. Both of those methods will work. Since 2 is a smaller number, I'm going to choose to multiply the first equation by -2. So when I distribute that through, it's going to be rewritten as -6x minus 2y equals -22. Okay, I made sure that like terms are lined up with each other. So when I add these, -6x plus 6x is a 0 pair. 3y plus -2y is +1y. And 24 plus -22 is +2. So when y is 2, we can plug it in and figure out what x is. Subtract 2 from both sides. We get 3x equals 9, and so 1x must be equal to 3. Okay, write it as an ordered pair. X is 3, y is 2. All right, final example for our notes today is a word problem and how to set that up. So in the table, we have some results of a test that you and your friend both took. Part A, write a system of linear equations. My suggestion is to always write down what your variables are and what they represent. We're trying to figure out the number of points that each type of question is worth. So if I say that M represents multiple choice, and S represents short response, then at the end, it's really easy to tell what goes with what. So the first equation I'm going to write represents your information. So I have this and I have this. So multiple choice, I got 23 of those correct. So 23 times the number of points each of those would be worth, plus 10 times the point value for the short response, all together should equal 86 points. Okay, next equation will be for your friend, and your friend scored 76 points. So this time we will have 28m plus 5s equals the total of 76 points. Okay, we're going to have to figure out a way to get the coefficients the same. I noticed that 5 goes into 10 twice. So if I multiply everything in the second equation by -2, then that should give me some equations I can use. So that would become -56x minus 10y equals -152. And then I'm just going to copy the 23, oops, not x and y, sorry about that. So this would have been M and S. Okay, and recopy the equation for your point values, just like that. Okay, so two separate parts. Now I can go ahead and add these two equations together. This is going to give me negative 33m, these are zero pairs, equals negative 66. So we'll go ahead, divide both sides by negative 33, and that tells us that each multiple choice question was worth 2 points. All right, if multiple choice is worth 2 points, I can take one of the original equations. So let's maybe stick with the one in blue. So 28m plus 5s equals 76. So m is equal to 2 points. And then 28 times 2 would be 56. Subtract 56 from both sides. So 5s is equal to 20. And then that means that 1s would be equal to 4. So short constructed response are 4 points each. All right, thanks for watching. Again, elimination is best used when you have equations that are both in standard form. And good luck solving these.